Welcome to Safety Spectrum, your environmental health and safety connection. This program is a presentation of the Michigan Safety Conference. For almost a century, the annual conference has provided credible educational opportunities and valuable support to the safety and health practitioner by offering 120 instructional programs, along with exhibits highlighting the latest in safety equipment, instrumentation, and demonstrations. To learn more about the conference, please find us at safetyconference.org.
Welcome to Safety Spectrum. I'm your host, Sheila I. This program is sponsored by the Michigan Safety Conference, and our topic today is Yours Forever, the PFAS Dilemma. You know, our ability to create materials and substances through chemistry, which address a need or mitigate a hazard, sometimes creates some unexpected and unwanted results. Though initially helpful, as science progresses and methods of detection become more sophisticated, we often find ourselves with potentially hazardous emerging contaminants. Our guest, Jeffrey Bolin, is Vice President of Technical Operations at the Dragun Corporation. In his role, he manages and oversees the consulting, litigation support, engineering, and environmental compliance, remedial investigation, and operations of the company in both the United States and Canada. Jeff is a frequent speaker on environmental issues at conferences and in the past several years on the issue of per and polyfluoroalkyl substances. He is presented at the Michigan Safety Conference and the American Chemical Society, just to name a few. Jeff holds a BA in environmental science and a master's in hazardous waste management, as well as a CHMM certification. He has been an adjunct professor at Lawrence Technological University, where he taught environmental management. So thank you for joining us today, Jeff.
Thank you for having me. I look forward to chatting with you about this topic.
It's a very diverse topic for sure. So there's been so much consternation and concern in the media related to the widespread use of PFAS in many consumer products and manufacturing processes. What exactly are they, and where are they used?
Well, first, I think maybe as you mentioned, PFAS are an emerging contaminant. The definition of an emerging contaminant is one that it's present in the environment, but we don't really fully understand the risk that they pose. So we don't have all the questions answered yet. And emerging contaminants aren't a new thing by any means. Through my career, if you think back around asbestos and PCBs and DDT, those all were things that were used in our products and used out there, became an emerging contaminant. When they got into the environment, people started to look at what the effects were on populations and human health in the environment. So from that standpoint, PFAS are in that emerging contaminant genre at the moment. But let's try and kind of tackle your first question, what exactly are they? And it would seem like an easy question to answer, but it's not as straightforward as one would think. Many people, you read articles and many people think of PFAS as an it, but PFAS is a they. They're, as I think you and others listening to this will find very quickly, it's a they. And it depending on how you define them, the number of PFAS in the family of chemicals can be somewhere between 3,000 upwards of and over 10,000 compounds.
Ouch.
So very, very, very large. So getting to it a little bit more as to what exactly are they. PFAS are a family of man-made chemicals that were introduced back in the 1940s. So they've been around. And the family of chemistry has a lot of characteristics that made them very popular in products. Those characteristics include water and oil repellency. It includes heat resistance and surface tension reduction and non-stick properties, just to name kind of a few, and those were some of the key ones. But based on those characteristics, it's a wide group of characteristics, had a wide application and variety of use in industrial and commercial products. And trying to get to the exactness part of it, just looking at it strictly from a chemistry side, PFAS are a straight chain carbon chemistry where the carbons are bonded to fluorine, and the fluorine atoms and the carbon bond, that's that man-made component, is very, very strong. And that's what gives them their forever moniker. It doesn't break down easily in the environment. It doesn't degrade very easily. And so therefore they are very, very persistent when they get in the environment.
So their properties would help work for fire retardant or for containing oils and greases, that kind of thing.
Absolutely. Absolutely. And we'll talk a little bit about how some of those things get in there. I should probably point out, again, very vast family of chemistry. The main focus up to this point has been on really two main compounds and of a PFAS, and that's and it's a myriad of acronyms. You
Science lives for acronyms, you know that, Jeff.
Yes, you spelled out the per and fluoroalkyl substances, or PFAS. So these two specific compounds are PFOA and PFOS, and they stand for perfluorooctanoic acid and perfluorooctane sulfonic acid. We'll stick to the acronyms.
Thank you very much.
And PFOS. But these were some of the most widely used and manufactured. That's why they came to the forefront earlier, and there's more known about those two compounds, and that's where the focus was. Now, it is expanding almost daily as to other PFAS compounds that they're looking at, and there's been replacement compounds for these two, which are no longer used in manufacturing in the US. So there's been replacement chemistries. So it is constantly expanding the breadth of how many of those 3,000, 10,000 compounds we're looking at. But there's still quite a bit, even though we know most about those two, there's still a lot of scientific banter as to the specifics of the health and toxicological effects and at what concentration. So really kind of what is safe along that line. And I think your second
where they're used
question is where they are used. And it's
we run into them,
Yeah, it's probably a shorter list of where they haven't been used. But we talked briefly about the forever moniker, chlorine, the fluorine carbon bonds. But it's really an everywhere moniker as well, because of so many uses for them, and they're found in so many places. Recall some of their properties we talked about, and if you think along that line, PFAS compounds were used and are still used in some instances in nonstick cookware. So think Teflon for an example. Waterproofing, and from that waterproofing side, you can think about outdoor clothing, Gore-Tex, things of that nature. Stain resistance, Scotchgard, carpet, upholstery.
And the good part is that it's the longevity of it. It doesn't break down. So these substances work very well in those instances, however.
Absolutely. Absolutely. And then you think about, and this is where it gets a little tricky sometimes. You think about the grease resistant side. So they're used in fast food wrappers, pizza boxes, microwave popcorn containers, lipstick, dental floss, ski wax. You mentioned firefighting foams, mist suppressants. The list goes on. And, people often think, oh my God, it's PFAS. It's this emerging contaminant. They hear all the bad stuff about it. and they think of some ugly, nasty industrial whatever, but they don't necessarily think about the everyday things that they're in, like cosmetics, and dental floss and food wrappers.
When we talked, you talked about mismanagement sometimes with substances that work well, such as asbestos. I mean, it's still a great fire resistant material, but it's how you handle it, how you remove it. And if you don't handle it correctly, how it can get into affect the health of someone.
Sure. And, I think with any chemistry, it's about management. I think back, I mentioned, one of DDT was the one I think I brought up earlier. And, DDT was used partially, to prevent mosquitoes and things like that, and therefore had a wonderful effect on malaria and things of that nature. But people thought if a little was good, a lot must be better. Okay. It was mismanaged. It got out there and took the path that it did. PFAS, again, hasn't been on the radar that long as a contaminant. Early 2000s, it started to come into play where they were starting to find it. So it hasn't been, in the crosshairs that long. And some of the differences between the previous emerging contaminants that we talked about, they were for relatively focused, relatively small group of chemistry, where this is a very wide group of chemistry and used everywhere. So it shows up in a lot of places.
Well, there's been, some media coverage. What operations have been like the recent focus of PFAS? What's coming up now?
Yeah, recent relative in a lot of ways. As we mentioned, they've been used in a lot of places, but certain industries and certain places have kind of been the bullseye where people are focused on it. And when they were started to come into focus as an environmental contaminant, mostly started with military bases. And the military has programs when they close a base out that they investigate those bases for residual contamination, and it's a constantly evolving thing. In the early days, they probably just looked for unexploded ordnance.
Probably a good idea before you pass it on to someone to develop.
Yeah. But then, then they started bringing chemistries into it, and it's been an ever increasing number of compounds that they look for. And through those investigations, PFAS became, and specifically PFOA and PFOS, came up as a chemical of concern at these sites in soil and groundwater. And as they connected the dots and looked at why are we seeing this, it was linked to their firefighting foams. So, often referred to as AFFF, which is aqueous film forming foam.
That's really great stuff.
It is wonderful stuff for putting out the fires it's designed to put out. And the military, if you think about it, the military is kind of process obsessed, and for good reason. They're process obsessed, and as a result, they practice things. And one of the things they want to make sure they know how to do is put out a fire when it starts. And they had this foam that was used to do it, so you had to know how to use it. And so they did practice of setting things on fire, putting them out with this foam. And as a result, those chemicals seeped into the groundwater and contaminated groundwater, and they found them at these military bases. So I mentioned kind of connecting the dots, and to your point about what operations that they've been used. So AFFF isn't only used by the military. AFFF is used by municipal airports.
I was going to ask that if municipalities are being affected by this.
Absolutely. So airports are a focus right now and being looked at. And also municipal fire departments would have some on hand in case they came across a situation that required the foam for as the extinguishment agent. And also chemical industries would have it in their system to put out if they dealt with petroleum related products that they were manufacturing and needed to put out that. So they became kind of a focal point of we should look anywhere that AFFF is being used.
Because it covers it, it encases it, and it holds the fire down. So
Well,
yeah,
it does that. It does that. One of the things I mentioned is surface tension is what it helps break surface tension. So the water creates a sheet rather than beading. So it takes the surface tension of the water and creates it as a sheet, and it suffocates the fire in a sense. That's part of what it does.
Remove the oxygen. Yeah.
Yep. And another focus recently is the plating industry, chrome plating specifically, but other platers as well, because in the same context of the AFFF, they used to use a foam for mist suppressant over their plating baths. And that was to keep the mist of the bath from getting into the air and protecting the employees that work there. That way it was an engineered control versus a PPE of putting on a mask. They would suppress the mist. The problem being the platers would discharge some of their waste to their sewer system or other places, depending. And some of this PFAS in the foam would go with it. So now it's in the sewer system going to the publicly owned treatment works. And the POTW is now has it in their biosolids, has it in their wastewater, is discharging it to surface water or where they discharge their biosolids. And so wastewater treatment plants became a focal point.
And it seems like years ago when I worked in a municipality, we used to be able to give the biosolids to the farmers and that, but you're thinking that's not a good idea. And they stopped doing it, which the farmers were upset about, but I'm not sure what it was they were afraid of passing on, but I think you're kind of telling me that.
Well, I'm sure it wasn't at the time PFAS, but giving biosolids to farmers is still a very prominent practice. And some may have chosen the one you mentioned that chose not to do it for certain reasons, but it's still a fairly prominent practice. And there's a lot of discussion in the agricultural community as well as in the municipal wastewater treatment community about what are we going to do if we can't continue this practice. The farmers have to look at it from their financial side of it's going to cost me to get amendments for my soil. The municipality has to look at it. If I can't give it to the farmers, I've either got to incinerate it or landfill it. And right now, a lot of landfills don't want it. So it really becomes a conundrum.
Well, what would be the result if a farmer did put contaminated biosolids on their fields?
Well, if they, it depends. And it depends for a lot of reasons, but I'll say we had an instance here in Michigan where that did happen. And again, it was all this connect the dots. There was a wastewater treatment plant that found it in their effluent. They started going back upstream. They found a plater that had discharged to them. And so they started to work with the plater to get rid of the source. But then on the other end of where they were taking their biosolids, they being Eagle, our regulators here in Michigan, started to track where your biosolids going. So they went to a farm that was accepting biosolids from this wastewater treatment plant. It was a cattle farmer. And they said, knocked on the door and said, I'd like to test your soil. And they did, and then they found a little bit. And then they said, we'd like to test your crops and your silage. And they found a little bit. And they said, we'd like to test your cattle. And they found a little bit. And they shut the farmer down.
Oh, gosh.
And so that's its own. And it becomes a very difficult situation because there are not really standards out there, let alone soil and groundwater. There are some now here in Michigan, but it's still a mixed bag. And when you get into food supply, there aren't really standards out there for these compounds.
Well, that leads into my next question. What's the status of regulatory actions for PFAS?
Yeah. It's funny. We're doing a podcast for call it 30, 40 minutes or whatever it is. And there are conferences out there that are 3 days, 5 days long on PFAS. So we're trying to cram a lot in, but on the regulatory front, as with much of the conversation we just had, the regulation of PFAS is in a state of flux. But I can say this, in general, they are ratcheting up or down, depending on how you want to look at it. They're ratcheting up in that they are coming, and they're ratcheting down in the levels and concentrations that they're looking at. On the federal level, the US EPA issued a PFAS strategic roadmap that spelled out their plans for 2021 through 2024 as to things they were going to do PFAS related. One of the key things that came out of that was they were looking to designate certain PFAS, specifically the PFOA and PFOS, plus a couple others, as hazardous substances under CERCLA. They were also looking at having companies report PFAS in their toxic release inventories, the TRI reporting that they have to do under SARA. They're looking to establish maximum contaminant levels under Safe Drinking Water Act, again for PFOA and PFOS in their drinking water, and as well as ramping up research on all those fronts, and research on laboratory testing and research on remediation and things of that nature. So while the federal government's moving at a pace, a lot of people and a lot of the public, a lot of the states even didn't think and NGOs didn't think they were moving fast enough. So it complicates things because a lot of states started making their own standards because they weren't waiting for the department, and they felt the pressure of communities and things to what's safe here, what's safe. So they started to generate their own. And Michigan, and I kind of say for better or for worse, but Michigan was really out there on the forefront of this. And in 2018, Governor Snyder established the Michigan PFAS Action Response Team, MPART, as it's referred to, another acronym, just because we needed that. But we were on the forefront, and a lot of states look to Michigan right now and look to MPART as a template relative to that. And they're not a regulatory agency per se. They report to the governor, but they coordinate the PFAS efforts amongst the agencies here. If you go to their website and look at their org chart kind of a thing, they have an executive director, but they also coordinate the efforts between certainly Eagle from a remediation and side of it, and looking at the environment side, Department of Human Health Services, MDARD on the ag side, the DNR on the wildlife side, MDOT from the roadside and some of the other things they do, and Department of Military and Veterans Affairs. All those agencies are involved with it under the umbrella of MPART in some form or fashion. And I think it just goes to show how far-reaching and pervasive the chemistries were, that they show up in all these, in some form or fashion in all these. More so than that, MPART, if you, again, going to the website, they developed and established 16 topical work groups. And these topical work groups are really the focus of specific areas of concern. Some of them we talked about, but drinking water being one of the main ones, because that's one of the key ways of having exposure to PFAS is through ingesting it. But drinking water, landfills, groundwater, air quality, airports, as we mentioned, wastewater treatment plants, as we mentioned, laboratory testing and figuring out how we test for these things, because it's not an established. Biosolids is part of it, but there's 16 of them, and those are all key focus groups as to how Michigan is addressing and kind of attacking this issue of PFAS and how they're looking at it.
It's much bigger than a bread box, obviously.
it is way bigger than a bread box. It
affects so many areas. That's what's kind of scary about the whole thing, but at least they're looking at the right areas, I think. Is it possible it could get designated under CERCLA as a hazardous material?
Well, if that part of it of designating at least PFOA and PFOS and a couple of others, if they designate those as hazardous substance under CERCLA, that will immediately bring a whole lot of focus on this to a lot of different companies potentially. It, you know, as you generate, now it's a listed chemical, and when you have a listed chemical like that under that, it starts to reach out into, from CERCLA into other regulation. It reaches out into due diligence when people are buying properties. It becomes part of the all appropriate inquiry potential. It becomes reporting obligations under things, possibly planning. You're going to have to really scrutinize your safety data sheets now to see, is PFAS in here? And you know, those things, safety data sheets are sometimes a misnomer in the sense, because if it's less than a certain percentage, you might not even have to list it. And we're looking at these compounds in soil and groundwater in the part per trillion range. So it's going to be interesting. I won't even say if it happens, it's when it happens. It's coming, and they're going to list it. It's coming. So
I know we can't cover everything that we need to, but one of my questions would be, what techniques could you use to remove or remediate PFAS? I mean, once you found them, and we don't really know what the standard's going to be as far as what's acceptable amount, how do you remediate what you have? Like, for example, the plating factory that you mentioned.
Yeah, it can be a nightmare, Sheila. It really can, because of these low numbers and some of the properties of these things. We've got clients that have had it in their processes and have had to try to chase it down within their plant as to where it was coming from, where they see it, where they don't. And some of these clients haven't used it for 10 years, and they're still seeing it in their effluent. And they either have to look at it as trying to treat it, and the two main treatment methods right now in a water is activated granulated activated carbon and ion exchange. Those are the two key ones. There's a lot of research going on for ways to take care of it, but that's one of the ones. So they either have to try to treat their water, or they start replacing parts, big tanks, big pipes, big things like that, to get it so they don't have it at the other end. There's a lot of research going on as to better ways. What I just talked about with GAC and ion exchange, all you're doing is taking it from the water, putting it on a different media, and now you have to deal with that media.
That would be the next question, exactly.
So what do you do with that media? Well, you either take it to a landfill or you incinerate it. Both are expensive. As I mentioned, landfills don't even want to take biosolids right now. Some don't, that come from a wastewater treatment plant. So it gets difficult on that sense. But there are a lot of research going on more destructive methods that actually do get in and break that bond and break that chemistry down. So we're not just moving it from media to media scenario. But they're just getting out there. I would say that, given the focus, and there are people out there, academics and others, that if you want a grant, make sure that your grant has PFAS in the grant language, and you're likely going to get it. If you tie that with climate change, you're almost certain going to get it. Get some money to do some work there. But that's the treatment side is tough, and most of it's, a lot of it's focused on water and wastewater, but it's in soil and it's in these other things too. So what do you do is a good question.
Well, has there been any definitive answers on health effects, or is that still being looked at, investigated? I mean,
I think
a direct relationship, collecting the dots, as you say?
Yeah, I think it depends who you talk to. From my perspective, I think the jury's still out. I think the toxicology is still making its way through. Again, we know most about PFOA and PFOS and not the others. And yet, that said, even though there's still a lot of banter out there, depending, again, American Chemical Council writes about certain things. They have organic fluorinated chemists on their staff. This is what they play with every day. They have a certain thing. The NGOs have a certain perspective. And I think one of the problems in it is we don't know there. I haven't seen any data that says specifically this concentration causes X in humans. We're not there yet with that. And that creates a problem in how clean is clean, to what level. And to put a couple things in perspective, I mentioned we're in the part per trillion range. A part per trillion, for perspective, is 1 drop of water in an Olympic-sized swimming pool. So that's a perspective on it. The EPA, prior to just recently, had a health advisory limit that they had set of 70 parts per trillion. And that was kind of what was out there. People were using that as a benchmark. Anyway, if I'm above that, maybe I got to look at it some more. If I'm below that, I'm okay. And the EPA just recently adjusted that health advisory limit to down into 0.004 parts per trillion. So from 70 to 0.004.
Ouch. That's basically none. I mean,
that's a part per quadrillion and levels. And they still want to use 0.004 parts per trillion, but move the decimal. And that, in my mind, I wrestle with why they did it, because they're going down the path of establishing some maximum contaminant levels under safe drinking water as part of their strategic roadmap. And I will be very surprised if those MCLs are not in the single digit part per trillion number.
Oh, that's going to be, so what do you recommend to your clients that come to you with a PFAS problem?
It becomes difficult. Here in Michigan, again, Michigan went ahead and did establish MCLs on their own ahead of the federal government. They established MCLs for 7 PFAS compounds. But I mentioned that we don't know the toxicology to a degree, and they're all different. I think that the lowest one is 6 parts per trillion. The highest one is 400,000 parts per trillion out of those 7 different compounds that they looked at. So that's a pretty good range out of 7 compounds, let alone 10,000. But here in Michigan, at least for drinking water, we have an MCL set up, so it by default becomes our cleanup standard for groundwater in most instances. And so if I'm dealing with a client that has that type of issue, I can at least look at a standard. And if we're looking at one of those 7 compounds. With the wastewater, it's a little different. They do have some numbers for discharges to surface water, so we're kind of driven by what the MPDS permit is for the wastewater treatment plant as to what we can deliver to them as a discharge. But it can be very difficult. State to state is different. There's very little continuity from state to state, so it can be a difficult question to answer. And the question sometimes becomes, do you look?
That's a provocative statement.
Mm-hmm. Mm-hmm.
So what recommendations do you have to our EHS professionals out here who may not have these kind of operations, but what should they be looking at?
Run fast. No. A couple of things. I would say, if you haven't already done so, take a look at the MPART website. Look at those topical groups and the matrix of that topical group and see if you fall close to one of those targets, either in your processes or if your facility is in the neighborhood of some of these target areas. Maybe you're next to a landfill or something, which is a focal point. Maybe you're next to an airport. Maybe you're next to a military base. Can you be brought in somehow through the connect the dots? So I would say that's one thing. I would say if they want to dive in deeper and way deeper than we're getting in this conversation, I would say go to the ITRC website. If you Google ITRC PFAS, you will have more information than you know what to do with on this topic and all the different rabbit holes we talked about. So that's something I would say if you really want to get into it, go to ITRC. It's a wonderful, wonderful resource. I would also say follow the regulations because they're changing quickly. And as I mentioned, if you have facilities in multiple states, you're going to have to look individually at these states, look at what's going on at the federal government. And, if you're able, comment on the regs before they become legislation. Get your thoughts known in there. On a smaller scale, if I can plug my own company, we have a PFAS resource page on our website. So it's something we try to follow all these things so we can try to stay abreast of what's happening.
Would there be a liability now with people trying to sell, vacant land or land that's housed some kind of operation beforehand? Is this going to be part of the evaluation you're going to have to do about what's in the soil? Are we there yet?
It's a yes and a no. Spoken like a true consultant, I suppose. If it becomes a CERCLA hazardous substance, it will absolutely be required because the liability protections you get under your all appropriate inquiry and due diligence, it falls under CERCLA, and it's driven by CERCLA hazardous substance. So if now compounds are part of the list, you have to somehow evaluate for the potential presence of them. It's so pervasive and so whatever, it's so everywhere. I've had these sort of tongue-in-cheek conversations with attorneys as to how do I not look for it?
Once we know something, right?
Not even without knowing almost.
No, that's true, that you're aware of something could be, yeah, right.
And at the concentrations we're looking.
Yeah, they're so.
How do I not find it at a part per trillion almost? Or one of them, I should say. Here I am using the word it. But how do I find one of them or not find? So it really is going to open up a lot of cans of worms as to what happens in the real estate market.
It's still emerging.
I already have clients that have me and counsel that say, as part of, you can do non-scope considerations when you're doing due diligence, and they will say, we want you to scrutinize for PFAS on the property as part of their due diligence.
They know just a little bit to be dangerous, huh?
It's,
Well, and this is kind of a facetious question, but why do you believe this topic is important? Now.
Yeah, because everything we just talked about, right? Again, they're persistent, they're pervasive. The regulations are ramping up. The science is evolving around all aspects of it. And there's a lot of litigation happening about it.
Already. Huh?
Already. Oh, man, lots of litigation. And, why do I think it's important now? It's probably more of a question of when PFAS will enter your world rather than if PFAS will enter your world.
Oh, okay. Yeah, it's a definite consultant answer.
I hate to be,
Oh, it's true. It's true.
Beating that kind of drum, but it's just the nature of the beast.
So any final thoughts? I hate to cut you, like you said, this could go on for days. But any final thoughts for me?
It could. Going down that litigation path and some of the other things, not only litigation, but even how people are, some of my clients as well, are finding ways to pay for some of the stuff that's happening. I would say for EHS professionals, talk to your management folks. And if you think you use PFAS some way, some fashion back in the day, locate, dust off, and hang on to those old insurance policies. Because those old insurance policies, they worked on a claims made versus occurrence type of scenario. And if attorneys look for those they didn't used to have the same exemptions that new ones had. And you can many times use that old policy to kick in and cover things that happened back then. So I would say that's something I would look at it. Attorneys scrutinize them if they can find them. And I would also say as you're renewing insurance, take a look, because the insurers are writing things into them to push away from their liability towards what's happening with PFAS now. So
be aware, be very aware. Well, it's like the right to know you have to keep records 40 years after somebody doesn't work for you. So all those exposures, you've got to keep track of it. So more record keeping. Okay.
Yeah.
I hear you. Well, okay. An insidious substance for sure. PFAS impact on human health is still under investigation. However, EHS professionals should remain vigilant and monitor its progress through their waste streams and water supply, and follow up on the changing regulations, monitoring its impact. I'd like to thank Jeff Bolin from Dragun Corporation. He can be reached at jbolin@dragun.com. And if you'd like more information on this podcast or the Michigan Safety Conference, please check out our website at michsafetyconference.org. Thank you for listening to Safety Spectrum. This is Sheila I.